This is the OSPF version 3 lab. Notice that we have two identical topologies. One is running IPv4 with OSPF version 2, and the other is running IPv6 with OSPF version 3. Let's go to action item number 1, capture packets and compare hellos. So let's capture packets here, and let's capture packets here, and compare hellos. So this is the hello for OSPF version 2. Notice that we are sending network mask here. This is used in order to check if two devices belong to the same subnet, but the philosophy of OSPF version 3 is not using the headers for prefix information or mask information. So this will not be sent in OSPF version 3. And notice that we are not sending anything related to the instance that we are using on our router. Whereas in OSPF version 3, we are not sending any network mask information here, and we're sending the instance ID. Let's go to action item number 2. At routers 1 and 61, compare the link state databases, specifically the router LSAs and network LSAs. So let's go to router 1 and see the network, the database. Notice that we only have 4 LSAs, and let's go to router 61 and see the database. And notice that we have 11 LSAs. We have more LSAs because we are now using link type 8 and link type 9. Let's examine one router LSA here. Router advertised 1111. And notice that this router LSA is sending what interfaces are being connected to the router, the type of interface, and the metrics. So far, so good. But notice that in OSPF version 2, we're also including the subnets and the masks, and even the IP addresses that are directly connected to the interfaces. The OSPF version 3 philosophy is not including this because this does not belong to the topology. Let's issue the same command here. And notice that we are only sending what interfaces are connected to the router, the type, the interface ID, which is only a number, and the metric. So in order to build a topology of the network, it is really not needed to know what IP address you are configuring in an interface, or to what subnet it belongs, or what is the MAC the mask, the network mask, or the prefix length. You don't really need that. You only need this information to build the topology table. Let's examine the LSA number 2. We are sending the network mask here. And let's examine the same network LSA here. We are not sending the prefix length. So LSAs number 1 and 2 will not send anything related to prefix length or any prefix. Let's go to action item number 3. At router 61, review the LSAs number 8 and 9. So let's go to router 6 and see that we have 4 LSAs of type 8. Let's examine one of them. So these LSAs will carry the link local address that belongs to each interface and the prefix. It will send. It will be carrying these two informations. Whereas the let's see the prefix LSA. It will only be sending the prefix and the prefix length. The difference is that the LSA number 8 has a link scope. So this information will only reach the routers that are connected to the same interface, whereas the LSA9 will make sure that this information will reach all the routers within an area. Action item number 4, compare the link state databases between router 61 and 62 and the amount of LSA. So let's see. And we have 11, we should have 11 here. And this other router 62, also runs OSPF version 3. And it has less LSAs because it only has one interface. So the number of links, LSAs number 8, will be reduced because there are only 2 routers connected to this interface for router 62, whereas router 61 has 2 interfaces and 2 routers per interface, so it will have 4 LSAs of type 8, whereas the LSAs of type 9 will be 3 because these LSAs have an area scope and will be the same for each router. Okay, let's go to action item number 5. Advertise a new loopback router 2 and 62 and compare the link state updates. So let's go to advertise these new loopbacks. Let's see how this is configured. Oh, this is wrong. I'm going to stop advertising this, and I will start advertising it again in order to create an update. I'm going to do this here as well. Here run it, face loopback 0. Okay, let's go to loopback 0 and issue OSPFv3, IPv6, area 0. And let's see the captures. Let's see, we have a link state update, and notice that this for OSPF version 2, it is creating an LSA number 1 or router LSA, which is a little bit of nonsense because we are only advertising a new loopback connected to a router. It doesn't make sense because the actual topology didn't change. We still have one link connected to router 2, which goes to router 1, and it doesn't make sense to send a router 1 type LSA. And let's see how OSPF version 3 handles it. It should be around here. This is the update, and OSPF version 3 will send an LSA type number 9. The topology didn't change. It's only just a new prefix that belongs to router 2. Router 62 is sent, so it rather use an LSA type 9 rather than an LSA type 1. And something interesting here is this there is an option here that will tell me what is the scope. Here is the scope. So the floating scope is 0,1. That means that this LSA will have to reach a whole area. So this code indicates that this LSA has to be flooded through an area. There are LSAs that have to be flooded through an entire autonomous system, and there are other LSAs like the LSA number 8 that only gets flooded across a link. So this is another difference between OSPF version 3 and version 2. That's it.